let's take a look here at glaciers, what they are, and the features that they leave behind when they erode an area. We have two kinds of glaciers. The first kind of glacier is a valley glacier. And if you think valley, you think that space in between the mountains, and that's exactly what a valley glacier is. A valley glacier forms at high elevations, way up in the mountains, where snow lasts year after year after year. So the snow never totally melts, it's always there, and it forms this compacted ice glacier up in the mountains. Currently, we have these valley glaciers in Montana, Oregon, Austria, in Europe, and in New Zealand, along with many other places. The second kind of glacier is what we call a continental glacier. And if we think of that word continental, it reminds us of continents, which are very large pieces of land. So a continental glacier is just that as well. It's a great mass of ice. It's very, very large, and it accumulates in high latitudes, so up near the poles. Currently, we have continental glaciers in Greenland and in Antarctica. One thing that is really important to know about all glaciers is that when glaciers come through an area, they're kind of like a bulldozer. They come in and they scrape everything down. And what they leave behind is a U-shaped valley. So if you look here, this valley has a nice curved U shape to it. And so that is evidence that this valley was formed by a glacier. We saw previously that rivers form V-shaped valleys. So the important distinction is that glaciers form U-shaped curved valleys. Glacial till is the sediment that is left behind by a glacier. And the important thing to know about glacial till is that it's unsorted. It's a mixture of all of the things that came in the path of the glacier. So glaciers, like I said, are like a bulldozer, and they're not picky. They pick up and leave behind anything that is in their path. So the sediment left behind by a glacier is unsorted. Now let's take a look at some of the features that are left behind by a glacier. The first one here is called a glacial moraine. A moraine is a ridge of till, so a ridge of sediment that is left behind by a glacier. If we look here to the picture on the left, this white section is an advancing glacier, so a glacier that is moving forward, and the moraine is the little pile of sediment that's building up in front of the glacier. So as the glacier moves, it pushes this pile, and this pile gets bigger and bigger and bigger. Eventually, this ice is going to retreat or go backwards, but this pile of sediment will be left behind. So this little hill that forms this ridge is called a moraine. If we look at the picture here on the right, we see that we get end moraines, moraines that are in the front end of the glacier, but we also get what we call lateral moraines. Lateral moraines are moraines that form on the sides of the glacier, but they are still a ridge of till that's left behind. Erratics. Erratics are another feature left behind by a glacier, and they are large rocks that have been deposited by the glacier. And the important thing to know is that they have a different type of rock than what's underneath it. So if we look here at this bottom left-hand picture, an erratic would be something like this big chunk of granite sitting on top of sandstone bedrock. We know that it was moved here by a glacier because it's so huge. A river would never be able to move this big piece of rock. But it's also evidence that a glacier moved it because it's made out of something different. So erratics are very large, and they're made out of something different than what they're sitting on top of. Drumlins. Drumlins are a ground moraine that has been shaped into a teardrop-shaped hill. And these are really cool because they indicate the direction that the glacier came from. So see here, we see this kind of teardrop-shaped hill, and we're going to look and see that it shows us which direction the glacier actually moved. So here we have a side view of a drumlin, and we see that it has this kind of steep side here and then a long, shallow side as well. If we looked at that in a topographic map style, we'd have a steep side here where the lines are close together, and a shallow side over here where the lines are farther apart. the direction of the ice flow is always from the steep side towards the shallow side. So it came from the steep side and it's going towards the shallow side. We could see that in this picture here as well. We have this blunt end or this sharp side, and then this tapered end, the shallow side, and the ice is going in this direction. So here's an example of real life drumlins or a drumlin field, and we might have to decide which direction was the glacier moving. Well, if I look at this picture here, I could trace the shape of a couple of drumlins here and see that they each have a steep side and a shallow side. So the ice, remember, moved from the steep side towards the shallow side. So it moved in this direction. And so we would say, based on the compass down here at the bottom, that this glacier moved towards the northeast. You try. Which direction was the glacier moving that formed these drumlins near Lake Ontario? Striations are another feature left behind by glaciers, and quite simply, striations are scratches in the rock that show which direction the glacier moved. They're formed because the glacier is carrying all these rocks and sediment with it, and as it drags those things with it, it scratches the rocks underneath it. So if we look at this picture here, we have these scratch marks that kind of go up and down, and we could trace them with a line like this. And if we look at this compass here, north is up. So we would say that the glacier was either moving north or south. I can't decide for sure because they move in both directions. So this glacier was either moving north or south. I could do the same thing with this picture here and trace my scratch marks this way. And so I could say that this glacier was either moving southwest down to this bottom corner or northeast up to the top corner. You try. Based on the compass and the striations that you see, what direction was the glacier moving?